Hello, everyone. Thanks for joining today. Just want to take a moment, introduce myself. My name is Adam Hoffman. I'm a senior controls engineer with Parker Hannifin. I'm located here in Murfreesboro, Tennessee, and am responsible for the controls and safety aspects of our pneumatic product line. So today I'm going to talk to you about one of those products, and that product is the P2M Industrial Ethernet. So this is a control module for network pneumatic valve manifolds. And when we talk about network valves, it may make sense to take a step back and kind of look at what we're coming from. So here's a brief overview of what it means to be hardwired or non-network. Basically, every output and every input on a system has a physical wire going back to a termination point. So you can see for 2 valves and 2 cylinders, you've got 8 wires. Whereas when we go to a network drop, you've got one communication line coming out to a control module and then controlling valves and bringing sensors, inputs, outputs back to one central location. So these networks could be anything from device net to Ethernet IP, Profinet, but basically just taking away the discrete wiring and creating a networked architecture. So this particular product, the P2M Industrial Ethernet, is going to be more what you're seeing here on this slide. So there's been a kind of a shift in industrial networks from years past, right? We've gone from more of a serial Fieldbus in the CC-Link, Profibus, device net era to more of what we call industrial Ethernets, okay? Each of them have their, I guess, where they may have started. So for instance, device net systems typically would migrate to Ethernet IP. Profibus is going to migrate to Profinet, right? And that's because these protocols are governed by parent organizations, right? So what we're talking about today is basically the slice in green here. So these are all the industrial Ethernets. And basically the market itself is really in the last, say, 10 to 15 years is kind of, taking over, and you're going to see a lot more Ethernet installations than you're going to see the old serial Fieldbus. So why would we use industrial Ethernet? Well, the advantages of network over hardwiring, wiring time, troubleshooting, the overall labor in the machine simplification, and a controls person can monitor the machine remotely via Ethernet to aid in troubleshooting. You can't do this with traditional discrete wiring, right? With discrete wiring, a guy with a screwdriver's got to go point to point, tighten every screw and wire to find where the problem may be, right? So this is going to be a lot more efficient. And when we talk about Ethernet, industrial Ethernet, we got to talk about the different protocols, right? So this module is capable of all of the industrial Ethernet protocols you see on the screen. And the big 3 here that I see that is going to be most of the installations, at least here in North America, are Ethernet IP, Profinet, and EtherCAT. In PowerLink and CC-Link, right? Those are going to be more overseas, but they do show up here in North America. And this product is a global product, so it's important that we capture all of the protocols that are out there. So for industrial Ethernet devices, they require configuration files. These configuration files, I guess the first question is, what are they used for, right? And why are there different versions? Basically, every protocol has a set of rules that devices must follow in order to communicate on that type of network. So the first one here, EDS file, stands for electronic data sheet and is synonymous with Ethernet IP networks. Okay, GSDML file is general station description markup language, and it's going to be a Profinet file. An ESI file is an EtherCAT slave information XML file. And basically, what's in this file is that it essentially tells the PLC how the data is laid out in memory so that it can be accessed. Okay, these are going to be different for every device on the market, and they're going to change with firmware. So it's important to get the latest version from the web page. So, and that web page is www.parker.com/pdn/p2m_IE. So the P2M Industrial Ethernet has a unmanaged Ethernet switch on board to allow for daisy chaining of Ethernet devices. So these devices utilize 4-pin M12 decoded connections. This is going to be your standard M12 teal or green Ethernet cables. For CC link, the coding is X coded, which is actually 8 pins, 8 wires that enables gigabit speeds. So again, it's not, unless you're using Mitsubishi controllers, probably not something that's real relative or important to you. The P2M Industrial Ethernet is capable of fast reconnection. So what this means is it is compatible with the Ethernet IP Quick Connect spec and also the Profinet Fast Startup specification. What this means is basically the device can be up and exchanging data within 500 milliseconds of connection. So within connecting that Ethernet cable and powering on, that device can be up and communicating in half a second. And why we care about that is if you think about end-of-arm robot fixtures where we may drop a tool off, go over, pick up another tool to do some other kind of process or application, you're going to have separate valve manifolds on each of those, right, to handle all of the air needs. So in doing that, we're not losing any production time to allow the device to power up, come up, figure out who he is, and start communicating. This is big in automotive markets, but it's also, it's also something we're seeing more and more across the board manufacturing. So as far as the valves series that we can connect this to, basically all of our valve lines are able to utilize this control module. The top module there is, or the top valve line is the Moduflex valves. So it's going to be a lighter weight plastic valve, great for that end of arm tooling. The second one down is our H micro. It's our 10 millimeter valve series. You get a high density of valves and a very small footprint. And it is a metal valve. And then our H universal down at the bottom is kind of our standard, which conforms to ISO standards. You have interchangeability across different manufacturers because of that ISO standard. So it also gives you the ability to mix valve sizes. So we can go from half a C sub V the whole way up to 6 C sub V on the same manifold. Another feature that's worth mentioning here for the P2M Ethernet is the safe power capable. And what that means is that the input power or the logic power and the output power or the valve power are galvanically isolated, and we can use this in a safe application. So now this device itself is not a safety device, but it is able to withstand a test pulse from a safety relay or safety PLC. And because the input and output power are separated, that's why we call this a safe power capable device. So what's the value proposition? We're adding diagnostics and prognostics to help you better understand the health of the product as well as predict and plan for maintenance events. We break the data into 2 buckets, cyclic and acyclic. Process status and valve control are implicitly updated on a regular interval, whereas parameter data is explicitly requested on demand. Competitor valve products require this explicit method for even the status data. So extra codes required to periodically check for problems that could be missed. So putting the status in our cyclic data gives us an advantage of knowing when there are issues and when we have to dig deeper to go to that parameter level data. So some examples of that data that's available is auxiliary power supply voltage monitoring. So we're monitoring the voltage on the auxiliary pins for the P2M Ethernet. We're able to set points to say what is acceptable on the low end and the high end. When we go outside of that normal range, we're going to set a flag or a warning to say, hey, there's an issue. That warning is going to be in process data, and then using that flag, we can then go down and explicitly pull the device and say, what was that voltage, right? So that is going to be what we call parameter data. So it's a little bit deeper level. It's not something we care about all the time. It's only when there's a problem we want to know, okay, what was the problem, right? Now, typically, this is not going to be a symptom of something going wrong with the P2M, right? Because this is a slave device. It's being fed power from upstream, but it could be an indication that there's something else going on in your application or in your process, that this can be used as a further troubleshooting or diagnostic tool. Every coil in the manifold has short circuit protection and detection. So again, process data versus parameter data. Process data, we're going to say there's a problem on one of the coils. Okay, you're going to get a flag. And then we can write a parameter data message and say, which coil was it that had a problem? We can tell you exactly which valve that needs to be replaced. So in times past, you may have to tear apart the whole manifold to try to figure out which solenoids are bad, right? So the idea here is ease of troubleshooting, quick turnaround times, and maintaining that uptime, right? Minimizing downtime. One of the last ones I'll talk about here is the channel switching cycle counters. And this is basically a counter for each solenoid. Every time that is actuated, we're keeping track of that, okay? And you may ask, well, why is that important? So anything with a mechanical component to it has a life, right? Friction, wear and tear, it's going to fail at some point. Now that failure may not be for 10 million cycles, but what we enable you to do here is maybe set a set point in a PLC to say, when I reach 90 or 95% of that life, I want to send a message to an HMI to say, hey, this valve is going to need replaced because it's going to fail. So being able to schedule that preventative maintenance versus unscheduled downtime is going to save you a lot of money, right? So at the end of the day, money talks. And also what we allow you to do is clear each individual solenoid counter instead of having to clear the whole manifold, because we also realize that if you replace one bad valve, or whether it's not bad or not, you replace that valve, you don't want to blow out all the counters on the rest of the valves in the manifold. So it's individual output or individual solenoid based. So as far as making this easy to use, we've gone and created function blocks for Siemens people or Omron people, and then called add-on instructions in the Rockwell world. And basically what this does is it packages everything up for the controls engineer and makes it easy to work with when we talk about parameter data. So process data, again, is the cyclic messages that are coming in automatically just by establishing communication with the device. Acyclic communication or parameter data requires extra code to go out and pull that device for that specific data. All of that code in these function blocks it's basically packaging that all up and simplifying it to turning on a bit and retrieving the data that you want. Okay, so we're going and doing a lot of the work behind the scenes for you, and you just drop in this instruction. So again, these are available the same URL as the EDS files and the GSDML files. The configuration, the manuals, everything is located at that one, parker.com PDN P2M_IE. I think one of the biggest things that makes this product stand out is the integrated web page. So we could do configurations, we can look at diagnostics. And actually, I think this is a good point. I'm going to show you a live demo of a P2M Industrial Ethernet that I'm connected to. So we can open up any web browser here, and we want to enter the IP address. I happen to know this IP address already because I use the rotary switches on the top of the unit. So again, this doesn't require any third-party software. This is built into every P2M Industrial Ethernet. Whether it's Profinet or Ethernet IP, this web page exists. The only exception to that is EtherCAT, because it doesn't have the native web server functionality. And that's specific to the protocol. So the first page that you land on is the overview page. This page is going to show the model name or part number, the serial number, the firmware version, and the uptime is the amount of time since the last power cycle. All right, so you can see I put power to this device 2 hours and 15 minutes ago. It's not real relevant right now, but think about a manufacturing cell and that's going to be powered down for maintenance or different things. These are just more informational parameters, not something you're going to use to control anything, but they're nice to have, right? So the next tab we have is the parameters tab. And this is probably the most important page in the web server. This page allows us to read and write to parameter and process data. The process data, it only allows us to control that if the P2M node is not owned by a PLC or robot. So if a PLC or robot has latched onto that connection, that's going to supersede anything I'm doing on the web page, right? And that's for obvious safety reasons. You don't want to be able to manually exercise a valve or change something mission critical on this web page when a PLC is actively controlling that and building parts or doing whatever. So everything that can be changed here also can be done by a PLC or robot. This includes the valve control, diagnostics like auxiliary voltage, and system commands down at the bottom here for storing the cycle counters, for resetting it to factory default, or leave fail state is basically an acknowledgement that there was a hard error such as a short circuit, right? So a voltage warning is not going to require an acknowledgement, but a short circuit is, because a short circuit's something that, hey, there's something physically wrong with this and you need to address this right now, right? So we've got this ability from the web page or from the PLC. So when you're changing data though, you must first log in. And if I try to change something, it's going to prompt me for that. So for instance, if I wanted to set this auxiliary voltage warning level to 19 and I click set, it's going to ask me for a password. I happen to know the password is Parker, and you can see that it took that change now. And it gives me a min and a maximum. This is the range that is settable for the low set point, and then there's a different one here for the high set point. Anything outside of those ranges, those extremes, that 18 volts or 28.5 is going to set an actual error on the device, and it's going to shut itself down to protect it from frying the device. So some of the other data points here, we have, like we mentioned before, the individual cycle counters for each solenoid, and then the individual solenoids themselves we can turn on, and we have an output state at loss of communication. So what this means is specifically, if I was to lose my Ethernet connection to a PLC or a robot, what do you want to do with the outputs? So if the valves are on and I lose my Ethernet connection, do you want to maintain that last known state? So if you think about a gripper holding a part and you're turning on that output to hold that part, when I lose that Ethernet connection for some unknown reason, do we want the gripper to drop the part or we want to hold on, right? So this is allowing us to modify how the outputs react in the event of a communication loss. The next page here is the network status. So this is kind of just general information again. The most important section here is up top. That's going to give you your IP address, subnet mask, and gateway. Some of the other diagnostics down here, some people may be interested in, but I would say most controls engineers are not real interested with this unless there's a problem. If there's an IP conflict, you may see some collisions and some packet errors here. And it's going to tell you, on each port where it's detecting those problems. So the last page here is the network configuration. And this is where we can actually set the IP address. There's actually 3 ways to set the IP address. There's the rotary switches, there's the boot P or DHCP tool, and we can also do this via the web page. Also, one other thing to mention here is that you can change the password. So by default, it is Parker, all capital letters. The username is going to continue to be Parker. You cannot change that, but the password you can change to whatever you want it to be. But just realize that if you change that to something and then forget that password, you're going to have to factory reset the device. There's no way for us to go in and actually see what the password is that you set. So rounding this out here, on top of the device, these are the rotary switches that I had mentioned that are going to help you set the IP address. But there's also LEDs for another way of diagnostics, right? So we're going to get diagnostics in the PLC and in the web server, but you can also see at a glance from outside the cell, is there a problem or not, right? Do I see red lights? Do I see an issue? So these network lights and the MS and NS lights, their operation is specific to the protocol that the device is. So Ethernet IP says that these lights for an Ethernet IP certified device need to do this when this happens. Same thing with Profinet, same thing with EtherCAT. So these are specific to the protocol. These are not just what Parker decided to do. So these will be consistent with other devices on the plant floor. So what about the manuals? So, when we talk about ease of integration, right? If I'm a controls engineer and I'm speccing out a product that I want to use, I don't want to have to read, a 200-page manual to figure out how to get the device up and running. I want it to be quick and easy. So knowing that, we limited this manual to only 19 pages. We think that, in those 19 pages, you can do everything you need to do. And frankly, we don't think you actually need to use the manual to get the device up and running. So some of the other competitive valve manifolds on the market and their page numbers to do the similar function. So I think it's just important to show how much emphasis is put into the product for ease of use. Another quick snapshot here is the ability to get the diagnostics. So we talked about the different methods, right? So process data in the PLC, the embedded web page, the LED diagnostics, parameter data, and the graphic display is one that we didn't mention. And there's only one guy on the board here that has that ability. So I think overall you can see how it stacks up as far as providing those diagnostics and prognostics. And one last tidbit here is we have another product coming down the pike, which is called our P2H Industrial Ethernet. And basically, this product is going to have all the same protocols as the P2M Industrial Ethernet. It's going to have the same flexibility with the right sizing of valves on the same manifold. We're going to add the ability to daisy chain not only communication, but also power now. And we're going to provide a lot of different power options. So you can see what's listed here is the L-coded M12, but there's also 4-pin, 5-pin, 7/8 connections. There's going to be M12A coded. So basically, whatever power scheme that your application utilizes, we're going to have the right connectors to it. So the idea here is to get rid of any kind of converters or any special cables. Off the shelf is what we're looking for. In addition to that, we're also going to expand the output capability to 32 solenoids.